Hey, welcome! Have you ever thought about math being like a giant explorable map? Well, today, that's exactly what we're going to do. We're going to become map makers and learn how to navigate one of the most important maps in all of math.
You know, this whole thing really starts with a simple game, Battleship. It's like this question Marissa asked her great-grandpa. How do you play without a computer? Well, how do you tell someone where your ship is hidden on a grid if you can't just point? You don't say, it's over there. No, you say it's at B5. And that simple idea, giving a precise location and address, is exactly what we're going to master today.
So here's our game plan. We're going to go from the basics of Battleship all the way to graphs. We'll meet the coordinate plane, learn how to plot points, then get into some really cool moves like resizing, flipping, and sliding shapes around. And of course, we'll wrap up with some practice to make sure you've got it down.
Okay, first things first. Before you can explore, you gotta understand the map, right? Every good map needs structure, and in our mathematical world, that map is called the coordinate plane.
And here it is. This is the coordinate plane. Now, I know, it looks like a simple grid, but this grid is the foundation for almost everything. We're talking charting stock market data, designing your favorite video games, you name it. Its whole job is to give every single point a totally unique, impossible to mistake address.
Let's break this map down, piece by piece. Just think of the x-axis and the y-axis as two huge main roads that cross right in the center of town. That center crossing, that's our starting point, the origin, and its address is always 0, 0. And you see how those roads divide the map into 4 sections? We call those neighborhoods quadrants. All right, so we know the layout of the town. Now for the really fun part, learning how to read an address, or what we call an ordered pair, to find any exact spot on the map.
Finding a point is just a simple two-step dance. You always start in the middle, at the origin. The first number in the address tells you how far to walk sideways, left or right, along that x-axis. The second number tells you how far to jump up or down along the y-axis. Just remember this, you walk, then you jump.
Let's try a few together. For point A, -3, 6, we start at 0, 0. We walk 3 steps to the left, then we jump 6 steps up. Bam, we're in quadrant 2. For point B, 2, -5, we start at the origin, walk 2 to the right, and then jump 5 down, landing in quadrant 4. You see the pattern, right? For C, it's right 4, up 3. For D, it's left 4, down 2. Easy.
Okay, so we can find any point. We're getting good at this. What's next? Well, now we start actually moving and changing shapes on our map. First up, making a shape bigger or smaller without messing up its form. This is called a dilation. And yeah, it's a bit of a fancy math word, but all it means is resizing something. You actually do this all the time. When you pinch to zoom on a photo on your phone, that's a dilation. You're using a scale factor to change the size. And the rule is super simple. It's all about the scale factor. If that number is bigger than 1, say 2, your shape gets bigger. We call that an enlargement. But if the number is between 0 and 1, like half, your shape shrinks. That's a reduction. It's really that straightforward.
Okay, so we can resize, got it. But what if we just want to move a shape around without changing its size? Well, that brings us to our next couple of moves, flipping and sliding.
First up, a reflection. And it is exactly what it sounds like. We're creating a perfect mirror image. You pick a line, like one of the axes, to be your mirror, and you just flip the shape right over it. The new shape is the exact same distance from the mirror, just on the other side. And you're not going to believe how simple the rules are. To reflect something over the x-axis, you just take the y-coordinate and flip its sign. That's it. To reflect over the y-axis, you flip the sign of the x. And that tricky-looking diagonal line, y equals x, you just swap the x and y coordinates.
And our final move is the translation, which honestly is the easiest one of all. It's just a slide. No twisting, no flipping, no resizing. You're just picking a shape up and sliding it to a new spot. And the instruction that tells us how to slide it, like move right 5 and up 2, is called a vector. Let's watch it happen. So we've got this triangle, and our vector, our instruction, is 4, -2. That just means move every point 4 units to the right and 2 units down. So we take each corner one by one. The first point is 0, 4. We add 4 to the x, we subtract 2 from the y, and our new point is 4, 2. We just do that for the other 2 points, and the whole triangle slides right into its new home.
Okay, you've learned all the basic moves, you're ready. Now it's time to put your new skills to the test. Let's do a couple of quick practice problems, you and me.
First one, imagine you've got the point 2, 3. Now, if you reflect that point across the horizontal x-axis, what are its new coordinates going to be? Think back to that rule. I'll give you a second. Did you get 2, -3? That's it. The x value stays the same, and the y value just flips its sign from positive to negative. Awesome job.
All right, one last one for you. This time, a translation. We're starting at the point 3, 4, and we're going to slide it using the vector -1, 2. What's the new address for that point? And the new spot is 2, 6. You got it. We just add the vector to the point. 3 plus -1 is 2, and 4 plus 2 is 6. You're a natural at this. So, to wrap everything up, let's just lock in these pro tips for success. 1. Your journey always begins at the origin. 2. Remember the order. You gotta walk before you can jump. It's always horizontal, then vertical. 3. Know your directions. Positive means right or up, negative means left or down. And finally, 4. Translations slide, reflections flip, and dilations resize. Keep those in your back pocket, and you'll never get lost on this map.
And that is your official guide to the coordinate plane. You are now a mathematical map maker. So I'll leave you with this final thought. Now that you know how this grid system works, how many things that you use every single day, from the GPS in your phone to the way characters move in video games, are built on these exact same simple rules? The map really is everywhere. Thanks for exploring with me today.